Hello. Thank you all for being here at this DevOps Tech Talk. And our first speaker of the night is Kevin Boats. And he's gonna give you a course about the
not liking it, that happens. You now have a lot of work that you either need to scrap or rework, and that's waste. So we make sure we limit work in progress, reduce batch sizes, and also, and this is a very important one, especially with these two words on the screen, reduce the number of handovers. What tends to happen within companies is that you have to do handovers to, for example, a QA team, an operations team, or in some cases have to go for an approval at a change board, perhaps things you've encountered in real life as well. And even with the best of intentions, every handover creates waiting times, which is a shame. It also results in the loss of knowledge and context about the change that's being made. Rarely these kinds of approvals are being given by someone who's actually seen the code, gone in, and understands how that works. The most important concept within the first way of flow is, however, the theory of constraints. I don't know if anyone's ever heard of this, but it's a theory that states that with any given process, any given flow, there's always at least one constraint that determines how fast your process could potentially be. And the fastest way to increase your flow, to make it faster, make it more efficient, is to continuously look for what the biggest constraint is, usually something like having to wait a long time for testing environments, or having to seek approvals from change boards that only come together once every 2-3 weeks, for example, and solve it. Usually with automation, especially in the case of testing, make sure you write automated unit tests, integration tests, etc. Execute them in a pipeline. I think we're going to see an example of that later tonight. Continuously identify the biggest constraint in your system and solve it. That's about flow. Then let's move on to the second way. And the second way is feedback, which represents the flow of information back from the right side to the left at any given stage in our flow, whether that be here, or at the end. Feedback loops all over the place. Our goal is to create and amplify feedback loops at every given stage in this flow. Why? Several reasons. We first off want to create an ever safer system of work that tells us if something is wrong and that we can fairly safely or feel safe making changes to. I'm curious, and this is a question for the audience, what kinds of feedback have you encountered in your daily work? Can you call out a few?
Build failed.
Sorry?
The build failed again.
Yeah, and why did it fail, for example?
How many reasons do you want?
Good answer. I like that. To just give you some examples, of course, automated testing is the biggest one in all its forms, whether it be unit, integration, security, anything that you think of there. Monitoring and logging are important sources of feedback. Dashboards are as well. But even something like developers being on on-call shifts, and that's a very unpopular one, I know. But if you get called out of bed 5 times per night, that tells you something about your system. That tells you something that needs to be improved. Also a form of feedback. When we do find something that fails, in this case, a broken build, for example, the second way tells us to swarm this problem with as many people that we can muster. For example, we'll have the entire team dive upon it and see what's broken, what we can learn from it. That way we ensure that not only one person is able to remediate and learn from this, and then happens next time, you'll be able to solve it a lot quicker. An important concept within feedback is also that we want to see problems as they occur. I already just said, I want to see the moment something fails, I want to be notified of it. Why? What commonly happens is, for example, you build a feature, you deliver it to a QA or an operations team, and they take their time doing their thing. They take 2, 3, 4 weeks, and then get back to the developer and say, hey, we found a bug or something. There's 2 problems with this. First off, the further you get into that flow, because by now we're likely already somewhere over here, the more expensive it becomes to fix. The more time and resources you'll need to spend on fixing it. To just give you an example, if you're able to find a defect in the design phase, that's already because things are going down and people don't like that. But there's a second reason. This is something that might sound more familiar to you as developers as well. Let's say you've worked on that feature, you've sent it off to a QA team, they come back 2 or 3 weeks later. Usually, at least when I do my coding, I'm in a certain frame of mind. I'm making conscious decisions, or sometimes subconscious decisions, on why solution A is better than solution B. Usually, there's a saying that the code that isn't written is even more important than the code that is written. And I'm not sure if this is a familiar statement with some of you, but it takes a certain focus, a certain flow to get into that state. If you have to wait 2 or 3 weeks for your feedback on the thing that you just built, you'll need to get back into that state. If I get that feedback within, say, 10 or 15 minutes, because, like you said, the build fails, or my test failed, then I'm still in that same state of mind. I'm still able to feedback loops this way. Let's see, I think I've got everything that I wanted here. One important aspect that I'd like to mention is of feedback that is pushing quality ever closer to the source. What tends to happen the moment that things start failing or we have outages is that people respond by implementing approval processes or inspection steps. You may have seen this as well, where operations teams are demanding lists and lists and lists of documentation, checklists, runbooks, etc. If you've ever read the State of DevOps report, again, something that I would absolutely recommend you do, it turns out that these manual inspection steps or approval processes, if done by someone else who did not see the code and has no context of how that code was written, actually degrades the quality of your product, and that's a shame. At best, it only lengthens the waiting time you have before that product makes it to the customer when it starts generating value. Again, a good reason to start implementing and amplifying your automated feedback loops in the form of test automation or whatever you can think of. That's in short the second way. So make sure we have feedback loops from right to left, and we use those to keep improving our product at the source instead of relying on inspection afterwards to see if it works yes or no. Then finally, third way, called continuous learning and experimentation. And here I kind of have bad news and good news, and I'm going to deliver the bad news first, which is if you choose to go on this journey to try to implement DevOps, the things I'm describing here won't be done in a day, won't be done in a week, won't be done in a month. In fact, I would argue that it never ends. The good news is that it never ends. That's fun. We always keep having puzzles and challenges to solve, which is what we find fun as IT professionals, right? The third way of continuous learning and experimentation goes into this concept and pushes it kind of to its boundaries. First off, we want to make sure that the improvement of daily work becomes an institution, that we reserve time to make process improvements in every week or sprint, whatever your choice is, and not do the, I will put it on the backlog and forget about it for 4 years, right, Rick? That's the thing that happens. I've seen this happen. But also, there's a culture shift that needs to happen when it comes to the third way, especially in regards to failure. One of my mentors used to say, congratulations, you failed. Better attention next time. That's extremely counterproductive. Rather, a failure should cause inquiry, should cause curiosity, should cause systemic improvements. There's a story I like to tell with regards to the third way and how you should respond to failure. I don't know if you've heard of the hack of SolarWinds, an American company a few years ago. They got hacked for several reasons, one of which was an insecure server password. And it was literally SolarWinds 123. I've seen parents implement better passwords on their parental controls on their TVs than that, so, not too great. And when news of this came about, the CEO of SolarWinds responded by saying, yeah, it was an intern. And that was it. That was the explanation. Okay. The DevOps community collectively sighed for good reason. Because it isn't the fact that an intern did that. That's not important. That's not important information. Anyone could have done that, essentially. What's more important, how is it even possible that that password was set at all? Don't you have password policies in place that enforce better passwords? Don't you have password management systems in place that save people from having to write this stuff down or make them so simple that they can remember them? That's kind of the reaction that we would expect rather than saying, it was an intern. There's a concept called post-mortems that you can do that I would absolutely recommend you search. Those are pretty much the reaction that I would like to see when it comes to the third way. rather than saying, you did something wrong, go fix it, or pay better attention next time. How can we learn from this? How can we improve the system so that we're not even capable of making this mistake again? Because we're always going to let down our guard. We're always going to lose paying attention because we all have hangovers, sleep badly, or we're just not in the state of mind. We'd rather go out and party than spend time on this incident, for example. So we start with enabling a safety culture as well as organizational learning. The last part of continuous learning and experimentation is kind of pushing the envelope. Because at a certain point, we'll be at a situation where we start running out of things to improve. And this is the moment we should start paying even more attention. This is where we start pushing the boundaries. We introduce what's called tension. An example of this would be, for example, if you normally run your pipelines on 4 different servers and load balance between them a little bit, try to see what happens if you put them under full load and then switch off 3 of the servers. That's introducing some tension. See how your system reacts and see how you could improve just that one server to see how it responds, and then implement it over all 4. You've suddenly caused a big improvement where you couldn't see one before. If you take this concept to the extreme, you get what's called resilience engineering, or even chaos engineering. All of you know Netflix, right? Yeah, stupid question, of course you do. Netflix took this concept to the extreme and introduced what they called the chaos monkey. It's a brilliant name, brilliant application. They've sadly decommissioned it since. But what they did in their very early beginnings was introduce the chaos monkey that, when activated, would go into their data centers and randomly start turning off servers. Whether that be database servers, front-end servers, back-end servers, didn't matter, just turn them off, see what happens. And then Netflix started paying attention to how people reacted. First off, how did they immediately respond to that incident? Were they running around, assigning blame, pointing fingers, etc.? Or were they gathering together, swarming the problem, and coming up with brilliant solutions? Well, the answer is the last one. Not only at fixing the immediate problem, which was that some servers were down and some services were unavailable, but also how could they prevent this from ever happening in the future? Implement load balancing to make sure that if a server drops off, it's automatically rerouted to the next one. And many other improvements. They got so good at this, in fact, that I don't know if you've seen the AWS outage of last year, where many major servers, including Twitter, I believe, and Facebook as well, were either unreachable or just not responsive because of a huge AWS failure. I can attest that there was one company, and I can attest this because I was not watching Netflix all day. My wife can attest to that. That stayed upright through it all, and was Netflix. Because they were paying attention and they were pushing the boundaries all the time, they were capable of surviving a huge infrastructure outage through application of that third way to get in. That's kind of the swarming aspect of it that I mentioned during the second way. That you always have some technical backup to fall back on, but in essence, it doesn't matter what the experience level of the people involved is, as long as they're thinking about how can I make an automated improvement based on what just happened. Does that answer your question?
Yeah.
Okay, thank you.
It's a bit of a follow-up on Rick's question.
Yeah.
Sometimes, most of the times when the outage costs money, it becomes difficult to the product owner not to blame. How can you? What is the best approach to tackle that with the client or with the owner? If you have, for example,
I would spend money outside of this discussion. Like, okay, that happened. This is going to have consequences. We know that. And then really focus on, okay, how can we improve this for next time? That should be something that speaks to them universally, right? This sucks, we agree, but we're not going to learn if we start finger pointing, blaming people, and making them feel bad, because at that point, the only reaction that you get is that people become scared to make changes. And then suddenly that product owner is asking, hey, why haven't you delivered on time? Yeah, because nobody's is brave enough to make changes, because last time they got slapped around. Yeah, that's a reaction that you would need to point out to them initially. Have that conversation, like, okay, I understand that you're frustrated, but this isn't productive. And really go into learning and reading about postmortems. I find that to be usually to already trigger kind of a switch in people's minds about how to tackle when incidents happen. Okay, shall we move on?
Sure.
Then thank you very much. And then Rick, the floor is all yours.
Yes.
Then I thought I want to go do game development as a professional. Moved on to a school to learn game development and web development. That was a necessity to do both. At a certain point, I realized game development isn't my thing. Well, web development was. Came at Competa, started working there, sent it to DBG as a front-end developer. After half a year, they asked me, like, we have a little bit of shortage of DevOps engineers. Can you maybe help them out because you said you thought it was interesting? I've been doing that for 2.5 years already. Currently in 2 teams as only DevOps, so I'm learning a lot every day, and I have almost every day I have new challenges. So that. What I'm gonna talk about is what does DevOps mean. I'm more going into the points that most people expect DevOps to be. Kevin already explained it beautifully, so I'm not gonna override that. What most people think when they hear DevOps, deploy monkeys, just people behind the PCs, just you have code, you send it to them, they deploy it on the server, and it's live and it's so awesome. Playing around in the terminal, because that's for backups plans. A lot of the time we're also collaborating with integrations. Let's say you have a website and another website, like let's say you have a small web shop of tech things, and Tweakers is coming to you like, hey, we have a small widget, we want to implement it in your site. As a dev, of course we can, but certain things has to be done from a DevOps engineer to allow that to make it in and to even get it to show. We also partly support the dev team. Like Nick said, it's more working together than working apart. Now I'm going into basic principles. A few things DevOps mostly use, which isn't quite understandable by sometimes devs, but mostly management, Scrum Masters, things like that. Words like instances, SSH, software on Linux-based distros. I'm going to show you. First, instances. Instances is actually just a very expensive word for owning a VPS, virtual private server. As an example, on the left, you see EC2 instances of AWS. Then you have a virtual machine of Microsoft. Then you have a compute engine of Google and a droplet of DigitalOcean. All different names basically means a server. That's the thing most people have questions about. It sounds a bit difficult more than it has to. SSH, secure shell. When you're seeing DevOps at work, you sometimes see him things like this, working in a strange terminal, which it doesn't look like normal. Secure shell is actually, that's why I put it right here, a way of just connecting to the server in a secure manner. On Windows, most people would do it without knowledge with things like remote desktop or TeamViewer, let's say, just to connect to the instance, just to see what's going on, just to change some things, maybe get some data. On Ubuntu, Linux, things like that, you sometimes hear them. You don't have even a desktop on Ubuntu, you have, but you mostly work from out a terminal. It's no necessity to have an interface, so why would you overload your PC when you can basically do it in the same thing? SSH is just an easy way to connect to your server via a very secure manner. Next thing I have is software. You have an easy install for like Macs, we all know that one. Windows and all the installer, you just press a few times next, agree, ensure, just take everything, install some things, swapping a little file to your applications, and that's just installing software. It's not difficult. But when we go to a Linux-based distro to install software, it will mostly look something like this. Green shell, weird things happening, weird commands, and all things pop up. Fun thing about this, it's basically the same. What we just basically say here, install this, remove that, and do it. For Linux, it's a little bit different because it's like more complicated. It's smaller packages you need. Where Windows is already packed with a lot of software and things pre-installed on an Ubuntu-based distro, you just have plain nothing. You have like a screen, just a little terminal, and you can install whatever you want. And the main benefit of that is you don't have bloat, because some things you just don't need. So that. Some things you will probably hear DevOps talk about. I got 2 points called Nginx and caching. Both of them you will probably hear from your DevOps are coming. Nginx, we're first going to start with. Nginx sounds complicated, but it is really not. I'm going to explain it really simply. What it basically does is it's coming from a domain to your code. You can see this as your delivery map. You have a package, you're coming to a big apartment, and you're just standing behind at the bottom at the desk. But you see that the load is quite big. And the main problem with having one server is, all the loads come to one server. There's one little mistake, one little in the shell, you accidentally install something wrong, or install something you didn't want to, and the whole server is down. What load balancing does is you can have 2 small instances instead of one big one. And Nginx is basically telling, like, when there are coming 10 people, they say, okay, you go to the first one, you go to the second one, and so it splits it. What it also does is checking if it's available. So it first actually would shout, like, to the first server, hey, are you still alive? When it doesn't have a response, it's like, okay. Calling the second server, he says, yeah, I'm fine. Send all 10 people to the second server, just to keep everything healthy. It's a way just of lowering your errors. Sometimes Nginx is used to do some caching. We'll go into that in a bit. It isn't used that much, like a little bit, but not mainly. At least I didn't saw it yet. What I told you, domain to server. You also have the code on the same server as Nginx has. So you install a piece of software, Nginx, and you tell Nginx, like, okay, my code is here. Someone comes in and just points directly to the code. What it also does is telling you how to react with path. For the devs here, if you're familiar with like Next.js or Laravel, they always have like routing in it for APIs or just pathing to show which file. That's nice and all, but the thing in Nginx is you also have to say which route to do what. In Laravel you have like index.php, but mainly when you come to index.php you just come to the home site. No extension needed in the URL. Once this is not configured in Nginx, like you're telling, okay, when you're in the home domain, just call index.php, nothing more. When you say, okay, but call after the domain, call index.php, the routing gets wrong and it just throws an error because it doesn't understand where it has to go. So that's a thing that's also application-based together with the server-based. Furthermore, we have caching. Well, I want to explain what it does, how it works. Simplified example once again, and cache bursting is also a part of that. Let's say you have a painting company. First job you have is painting somewhere, something like, let's say, a cabin. So you go to a hardware store, you get paint, you ask where it stands, you ask the price, you get it, okay. For the second job, you have to also paint a cabin. In that case, you're not gonna go to the hardware store again, ask it once again, like, okay, where's the paint? And you're not gonna ask, how much does it cost? Because you already know that. Caching works in a similar way. For the first time you arrive at a website without caching built up, you actually get all the files, every path, every asset, JavaScript, CSS, and you get that. But the next person who's coming, the server already knows, okay, you asked this last time, so here's your answer. I already know this one. And that works mainly within a period. What I mean with that is the point of cache busting. Let's say you have cache built up for 30 minutes. Normally you would let the cache die out or bust it. So people come and they have to load it again. And the main reason behind it is, let's say you go to, you have, as the painter, you have 100 jobs already. You can't assume that over a span of, let's say, a year, you can still go to the hardware store. They have that same paint still in the same cabinet, same location, of the same price. Sometimes you need to check if is it somewhere else, maybe it's cheaper, maybe it's more expensive. Sometimes you need to check if everything is still okay. Next point, why do you want caching? I have a small example below. I don't know if you can see this well. Well, no, I will zoom in a minute. I run a test on one of our servers. This is 500 concurrent users per second. That means every second new 500 users come in. This is the load of the server that was on it. As you can see, it's at 89%, which is not quite good for a server, and it's running constant. Like you can see exactly 9:21. I started with users. It's building up. It's building up. It's building up. And at a certain point, at 9:51, I was done. I was slowly building down. The server is really having a difficult time around that. When you have caching installed, like every time, without caching, every time the client gets a new response, the server doesn't know what to give, so it searches subs and gives it back. It's a lot of calculating it has to do. With caching, it already knows the calculations and knows the answers. It doesn't have to do it again. So here you can see I started at 12:45. We have a small peak. For the first time, the cache has to build up. After that, you don't see anything. Here is the point I just talked about, the cache bursting. The cache is just gone. It has to build up again. This is just, scale is a little bit off, but this is just barely 50%. It just gets a little peak. After that, it has cache again, so it doesn't have to calculate anymore, so it slows down. Let's see if we can get this done. Yes. So, this is what the server looked like at AWS, maybe while the outage of the last time. This is without the caching of the 500 concurrent users. With the caching, just a little bit foggy before the first test I ran, but still everything is fine. So that's caching and Nginx. Next point I want to talk about is the infrastructure as code part. That's the thing you also hear DevOps say a lot. Most of the DevOps use it as well. Now, what is it? When would you use it, and why should you use it? Let's say we buy a server, we don't know anything about infrastructure, we just buy one, let's say at FrenzyPay, €6 a month, sure, just install some things like where you saw on Stack Overflow how it would work, and nice, it works. That's a little bit too fast. The main issue with that is, let's say you have set it up, but you see that FrenzyPay is changing their prices and it's still getting more expensive till a certain point that you pay €30 a month. Okay, I don't want that. I want to go to a different provider for the same server, which is way cheaper. But let's say that's a span of 6 months. You still have to find that old Stack Overflow post you found then to know how you actually did set it up. There's no git log, there's no documentation probably, because most people just do a bit of clickety click and everything is fine. And you don't know what you have done. the reason why you should use it is just because it gives a structured way of creating it. Let's say, yeah, you want to build a server. First you have to think, okay, what has to be done with the server? So you calculate what you need, and then sure, you buy a specific server. You make it with code. That way you can see back like, okay, this is our current server. But let's say you have a small company, let's say you have a painting company, but you're at the IT department, you have 4 workers. It's Thursday evening, you're enjoying your beer somewhere in a cafe. And one person is at home because he was a bit sick. And he sees that the server is like at 80–90% CPU rate and sees that a lot of users, this is going to be you. When you don't want to do that because you have no idea what you have done. That's it. Any questions?
Yeah, usually when you have local development servers, they don't use stuff like NGINX. Is that just because it's too heavy or too difficult to set up locally?
It's not quite too heavy, but it's not a necessity to have. Mostly it uses Apache, but at a production server, I would put a serious caching layer before my server. I would set something up with Nginx and maybe have some things for production only in Nginx. You don't need that. I mean, like my example, you don't need that piece of code of tweakers in your development environment. You see it in production, so it works. You don't need that.
Does that mean that Apache is far easier to set up?
No.
So I'm sort of wondering why.
It's not easy to set up, but when you create a Docker file, most people use Buddha, some people still use Vagrant, it's easier for you to load, to make a simplified image of what production is actually like. At DPG, we have 2 boxes, one where you just have one server which runs on PHP, which has Node on it, and that's it. But we also have a version where you can spin up a production-alike environment on your local host. Just to check if production is the same, like your code is the same on production as well as locally. Any other questions?
So if you're saying that there's a lot of difference between local and production code, how do you manage the deltas, the changes between them?
You mean like an acceptation environment, or?
Yeah, I mean, like, say when you go into, the UAT environment should be the same as prod, but the dev to QA, it could be different. But then if you QA something on QA and then it changes before it goes to prod, that hasn't been tested.
Yeah, correct.
Bigger picture, because, well, as a web developers, we're living in the world of software as a service. And we basically just servicing our clients. And thinking about software as a service, we always want to improve this service. We want to satisfy our customers. And if we can bring our product as fast as possible and accurately as possible, then we are succeeding in competing our competitors. So one of the basic concepts that you probably maybe didn't hear about the name itself, but most likely you notice things from this concept in your development, because in case you use any of the frameworks, some things are just building into architecture, like for sure storing config in the environment. That's the thing that you see in any framework. If you know about .env file that you do not store in your repository, then you separating your configuration from your code, and you already comply to one of the 12 factors. And yeah, I didn't take all of them, and basically you can just go to the website and dig deeper into that. But those ideas are basically helping to improve your service, and that's also helping to build your CI/CD pipeline to make automation of your release process. I'm just throwing like random knowledge into your heads because we're just going to go into practice, and yeah, so you're going to get prepared. There are a lot of automation solutions. Didn't mention Azure and Jenkins and all this stuff. I was just too lazy to load all logos. But what I used personally, Bamboo is usual enterprise solutions, also in Kampman. And we're actually in the process of moving to GitHub and using Github Actions. Pretty similar, as you can imagine, like GitHub and GitLab, same for actions. On GitLab you can see a pretty same solution. And GitHub Actions is something that I used for my own pet project, and that's something that I would like to show you today. Basically, assuming that either you already have GitHub account and some repositories there, either it's pretty easy to register and store your code there. So we just gonna build a little bit of new thing on top of it, and you're good to go. So, speaking of practice, this is my case. This is my repo. I'm just going to show the actual thing. It's a React application, some stupid game remake that I did for. And there's nothing except React. And speaking about manual process, it's hosting on the. So I'm in. And there's a folder where I have my projects, and we are in. So this is the folder with the project. That's already compiled project, just the static files that are served by Nginx. That was mentioned today already. But if it would be a manual process, like I don't know anything about CI/CD, I would go with I did go with the approach that I have my code on GitHub. I just clone repository on the remote server, and every time when I push my code to the repository, I pull it on the remote server, go via SSH, pull the code, build the application, maybe restart Nginx, and then I have a fresh version of my application. For the sake of easy thing, so I have a configuration for this site here. So here, when I serve this website, this application, somewhere I have it. Yeah, so I just disable all cache. Basically, even by default, if you serve